Okay, so in the previous video I discussed experiment-wise error and planned and unplanned contrasts. In this video I will show you how to actually do planned and unplanned contrasts. So SPSS allows you to carry out specific hypothesis tests at the same time as you conduct the ANOVA or the omnibus F. You need to specify the hypotheses, which are called analytical contrasts. So let's say we want to compare the activity levels of children given no additives to those given preservatives, children given preservatives and those given colouring, children given no additives and those given any additive. Okay, I'm going to go to SPSS now, and I've got the data set open. The four groups, basically the hypothesis is that children's activity levels will differ according to their diet, specifically whether there's no additives in the food they eat, whether there's preservatives in the food they eat, whether there's colouring in the food they eat, or whether there's preservatives and colouring. So these are the four groups that are in the diet.sav data file, and then the DV is activity level. Okay, so we go up to analyse, compare means, one-way ANOVA. We put diet in the, sorry, no we don't, we put diet in the factor because that's our four groups, and activity level in the DV, and then we specify our contrast. So these are our planned contrasts. Now if we go back here, we start with the first one, children given no additives to those given preservatives. We need to actually specify the contrasts that we want to apply. So we've got these four groups. So if when you specify the contrast, you give 0 to any group that's not in the contrast, and you give contrast coefficients that of opposing valence to the groups that you want to compare. So in this one, we wanted to compare the group with no additives, so they'll be given a contrast coefficient of 1, to the group given preservatives. They'll be given a contrast coefficient of -1. So SPSS knows to compare the group given no additives to the group given preservatives. The group given colouring will get a contrast coefficient of 0, and the group given both will get a contrast coefficient of 0 because these groups are not in the comparison. The contrast coefficients given to the groups that are contrasting, are being compared, must add up to 0. So 1 and -1 will add up to 0. And you must put the contrast in the order that the groups were mentioned. So we looked up here and we saw that group 1 is no additives, so the group 1 contrast coefficient will go first. Group 2 is preservatives, group 3 is colouring, group 4 is preservatives and colouring. So we go up here, down to the one-way ANOVA, diet in the factor, activity level in the DV, and we go contrast. So no additives is first, and we're comparing no additives to preservatives. So we'll give no additives a contrast coefficient of 1. The next group was preservatives, which we wanted to compare to the no additives group, so we'll give that -1. And then the next two groups weren't in the analysis, so we give them 0. Every group has to have a contrast coefficient, so we just give them 0. Now the next comparison was children given preservatives and those given colouring, which were groups 2 and 3. So we go next, we give the no preservatives group a contrast coefficient of 0. For children given colouring, a contrast coefficient of 1. Children given preservatives. Children given colouring, a contrast coefficient of -1. And then the final group that was given both is not in the analysis. By the way, it doesn't matter which group's got the positive valence and which one's got the negative valence coefficient. It doesn't make any difference. The next one was children given no additives and those given any additives. We wanted to compare the first group to the second and the third group. So there's going to be -1 and -1 to the second and the third group. So the first group, no additives, has to be given a contrast coefficient of 2, so the contrast coefficients add up to 0. So when you're comparing one group to two groups, you must give a contrast coefficient of 2 to the one group and -1 to each of the other two groups, and then the third groups get 0 because it's not in the analysis. Oops, and then I forgot to specify the final one, which was children given one additive to those with both additives. So that's group 2 and 3 to group 4. So the group 1's not in it, the no additives group isn't in it, and then group 2 was one additive. Group 3 was one additive, so they're both being compared to group 4, which was both additives. So that gets a -2, so the contrast coefficients add up to 0. We press continue. activity levels not in the DV box for some reason. Go to options, always ask for descriptives and homogeneity of variance test. We press OK, and we get our results. So there's our descriptives. So the number of, we only had 5 participants in each group. They're their mean activity levels and the standard deviation, 95% confidence interval, which we don't report in ANOVAs. Levine's test, the test of homogeneity of variance. So you can see it's not significant. So there's no evidence that the variances of each, the populations from which the samples were drawn, is unequal. Here's the results of the ANOVA. So you can see that F is quite large and the ANOVA is significant. So the omnibus F is significant. So we know that at least one of the groups differs significantly. These are the contrast coefficients we specified for each of the 4 contrasts. And these are the results of the contrast. So these are the results if Levine's test is not significant, and these are the results if Levine's test is significant. So you can't assume equal variances. We want the first row because the first lot because our Levine's test wasn't significant, so we can assume that equal variances. So this first contrast, we compared no additives to the preservatives, and we can see that that just differed significantly. We need to make an adjustment of the p-value by dividing alpha by k. So I'll just get my my calculator out, and we need to see. We need to do 0.05 divided by 4 to keep a experiment-wise p-value of 0.05. So we've got 0.0125. So this did not differ significantly. The second one, which compared preservatives to colouring, did not differ significantly. The third one, which compared no additives to any additive, did not differ significantly. So the only contrast that differed significantly at a p-value of 0.0125 was comparing 1 additive to 2 additives. So that's what you would write in your report. Okay, so that's unplanned comparisons. I've done all this because we just talked about it ourselves. Alright, so, and I've done all that as well, so I'll go down to student Newman-Kuhl's, which I'll just have to escape from here for a moment. Hold on a second. Oops. So unplanned or post-hoc comparisons. So the probability of making at least, I'm going to start the current slide. The probability of making at least one type 1 error in the set of unplanned comparisons is 0.05. So unplanned comparisons is where you compare every possible pair of groups to each other. Applying these post-hoc tests is equivalent to each individual unplanned comparison being at a much lower significance level. We tend to use the student Newman-Kuhl's. So when you go to SPSS, if you want to use student Newman-Kuhl's instead of if you don't have any specific hypotheses about which groups are going to differ, you can go, when you run your test, you go compare means, one-way ANOVA, and instead of doing contrast, you go post-hoc comparisons, select SNK. You wouldn't do the contrast in that case, so we'll, how do you clear that? You have to go through and clear each one, so I won't bother doing it. Normally you can just press reset. And we get our post-hoc test here. So basically with post-hoc tests, groups that are in the same column do not differ significantly from each other, okay? Groups that are in different columns do differ significantly, as long as there's no repeat groups. I'll show you what I mean by that in a sec. So basically this post-hoc test shows us that the preservatives and the mean activity levels of children who are given preservatives and colouring differs significantly from the mean activity levels of children who are given no additives, colouring only, or preservatives only, but the mean activity levels of each of these groups do not differ significantly from each other, and that's the p-value for these 3 groups, okay? Don't worry about this p-value saying 1, just ignore it. You just have to say student Newman-Kuhl's in brackets alpha equals 0.05 shows that the mean activity level of children given preservatives and colouring differs significantly from the mean activity levels of children given no additives, colouring or preservatives, and then you don't have to give any more statistics. You'll see examples of that in the textbook. Let's go to the textbook and have a look at some more examples of student Newman-Kuhl's. Let's have a look. Was it in here? So here's an example. Suppose we were interested in the difference in positive affect for participants with different occupational status. We've got unemployed, home duties, and employed full-time. Here you can see that the unemployed people have their mean positive affect of 19.45 is in a different column to the mean positive affect of those doing home duties or who are employed full-time. So you would say a post hoc student Newman Kuhl's test, in brackets alpha equals 0.05, shows that mean positive affect for unemployed people is significantly lower than the mean positive affect of those conducting home duties or employed full-time, whereas the mean positive affect of these latter two groups did not differ significantly. Now here's a more complicated one where you've got some groups in two columns. So what that means is that these groups did not differ significantly from the groups in the same column. So in this one we're interested in the difference in ego strength for children raised in different home environments. So the ego strength of children who are living with other relatives or one parent does not differ significantly from children living with both parents, and they do not differ significantly from children who live with unrelated persons. The only groups that differ significantly, the mean ego strength of children living with both parents is lower than the ego strength of children who live with unrelated people, significantly lower than the ego strength for children who live with unrelated people. Okay, I hope that makes sense.